This is question on linear programming and November 2013 and variant 41. Find the equations of the line L1, L2 and L3. The equation of line of L1 is it is just a horizontal line. It just cuts y-axis. So equation is y is equal to 2. It cuts y-axis at 2. Therefore, equation is y is equal to 2. And the second line, this L2, which passes through the origin, and it is little bit slopy line with having some gradient. So we will use the formula mx plus c. The c is y-intercepts. Y-intercept. So y-intercept is a point where the line cuts y-axis. This line cuts y-axis at y. Here it is the y is 0 here, so y-intercept is 0, c is 0. To find gradient, we can use a formula or rise or run. So to find rise and run, so let me take any 2 points. Let me take this point and draw a right angle triangle. This is rise and this is run. Rise is 4 and the run is 2. Therefore gradient is rise over run, which is 4 over 2, and 4 over 2 is 2. So the equation of line, this line is y is equal to mx plus c. So therefore its equation is y is equal to m is to 2x and c is 0. So it is y is equal to 2x. This third line, which is L3, it is also a slopy line having some gradient, and to find this equation of this line, we again use y is equal to mx plus c. Here c is y-intercept, which is 5, and to find this m, gradient, rise over run, so let me take any 2 point of this line and draw a right angle triangle. It is run, which is 10, and it is rise, which is 5. Okay, so rise over run here, rise over run is 5 over 10. And student, this line is coming down. It is coming down. The line which comes down, the gradient is negative. So let me put negative sign in. Finally, the gradient is minus 1 over 2. Equation of this line is y is equal to mx plus c. M is minus 1 over 2x and c is 5. Now we have found equations of all the 3 lines. The part B, write down the 3 inequalities that define the shaded region. The region is bounded by these 3 lines. These are the boundaries of this region, which is here. So the region is it is upward of this line, so therefore the inequality of this will be greater than equal to 2. And line 2, this region, this is also the boundary of the region, and region is towards this direction, towards this. When we move towards this, so you can observe when you move towards this, the values of x keep on increasing. So inequality is y this x is greater than equal to y. And now this third line, this is also the boundary of this region. If you move this direction, you can observe y is decreasing. Y is decreasing. So if this inequality of this is y is less than equal to minus 1 over 2x plus y. You can take either x or y to find the inequality. A gardener buys x bushes and y trees. The cost of a bush is $30 and the cost of tree is $200. The shaded region R shows the only possible number of bushes. Find the number of bushes and the number of trees when the total cost is $720. First, let's calculate the total cost. The cost of one bush is 30. And there are x bushes, so total cost is 30x. And the cost of one tree is $200, and there are total y trees, so the total cost is 200y. And the total cost of both bushes and trees is 30x plus 200y. Find the number of bushes and the number of trees when the total cost is 720. As we don't have to find maximum or minimum. In case there is a maximum and minimum, then we use only corners points. But right now it is not the case of maximum and minimum. So we will check all the points, whether they are in the region or they are on the border of the region. And we put one by one x and y in this and see where the cost is 720. As x and y represent bushes and trees cannot be in decimal. So we will use whole numbers for both x and y. So what points have the whole number? So this point is on the border. Border is the part of the region. This point, it has coordinate 1, 2. So 1, 2. And then this point, this is also the part of the region 2, 2. And likewise, this one, and also this one. The next point where we have whole numbers, it is this 2, 3, and then this one 2, 4. Okay, and this one as well. This point does not have whole number. This is 3 point something. So we will ignore this. And what else? And this one 4, 2.8 no. And this point, yes, this point which is 4, 3. Okay, so I think there is no more points where the x and y both are whole number. So let's plug in all these points one by one in this cost function and see where the cost is 720. So I put in this function 1, 2, this point, and let's see what is the cost. 430. So at this point the cost is 430. And likewise we keep on putting the points, all these points one by one, and see where the cost is 720. At this point where number of bushes are 2 and number of trees are 2, the cost is 460. Okay, so when we put 4, 3, that is 4 bushes and 3 trees, we get cost 720, exactly this cost. Okay, so the number of bushes, so number of bushes should be 4 and number of trees should be 3. 4 and the number of trees should be 3. Then this function will give us the cost $720. So these are the answer of this part. Okay, the next, find the number of bushes and the number of trees which give the greatest possible total cost. Now the question is greatest possible. So when it is greatest, minimum, maximum, least, we put the corner points. So let's put the corner points. Now these are the corner points. This is the corner point, one corner point. This is second corner point. This is third corner point. Let's put these corner points and see what is the greatest cost. Because the greatest and the least and minimum, the corner point will give you the least and maximum cost. So let's put this point. We have already put this 1, 2. Okay, so here we have the value. It is 430. Now let's put this 6, 2. 6, 2. And this point is 2, 4. And see what is the cost. Okay, putting these 3 corner points, we get the total cost, and out of these 3 points, which is one is over here, second and third, and the highest total cost is 860. Okay, so the greatest possible cost is $860, and it is right on the greatest possible cost, and it is just using 2 bushes, x2 and y trees, that is 4.